Today, energy consumption and its environmental impact are heavy concerns. Several studies pointed out that many household appliances have a strong environmental impact due to their high energy consumption and especially due to their amount of wasted energy. In order to reduce this consumption as well as the impact, product designers should optimize the energy consumption of these household products. On the other hand, previous surveys informed us that the progress in this direction is not optimal because the method of designing for sustainability is quite complex and time-consuming. Therefore, extra support in the form of a software tool is needed for industrial designers in this direction. This research is aiming at a development of a software tool that is able to support designers in the conceptualization of smart energy saving by applying ubiquitous technologies. During our previous research and design actions, the basic principles, the functions, the operation, and the functional framework of a proper tool were developed. To optimize the design of the tool, we would like to discuss the working principle, functionality, and implementation of the tool with all stakeholders. We found that at least 3 groups of stakeholders should be invited for a discussion to be able to learn their opinions and improve the tool. These stakeholders are product designers, who will be the future end users, software developers who are involved in the programming and constructing of the software tool, and knowledge engineers who are involved in the knowledge representation of the tool. Separate sessions will be organized for the 3 groups of stakeholders, and, in addition, this explains why we have invited you to take part in this focus group session. The experiment is based on a methodology which is called Modular Abstract Prototyping. To be able to show the affordances offered by the tools to you and the interactions with the tool through the use of modular abstract prototyping, we put the tool into real-life context and present all features that need to be known for you in order to be able to give proper judgments and propose possible improvements. Our objective is to present factual information about the tool and to collect and to discuss your opinion about the concept, framework, functionality, and implementation. We will present you an abstract prototype demonstrating the real-life use of the tool. We will show you how the tool can support finding solutions for smart energy saving by applying ubiquitous control solutions. We will also demonstrate how the tool provides additional knowledge for designers in the form of past product cases and available technologies. Consider now that you are the designer using the new tool in development of a more energy-aware household appliance. As we have to consider that many more users can apply the system, we generalize the users as a persona. Let's call this persona Harry and put him into the role of an experienced and creative designer. The abstract prototype will show his actions and his use of the tool in problem solving. You also have to know that Harry is a product designer who is working in a small design office, which is specialized in the development of electronic household appliances. His last client asked him to develop a new mobile air conditioning appliance. Now Harry's in the concept development phase of his air conditioner. Actually, he is now busy with collecting and considering all requirements. One of the major requirements is that the air conditioner must be as energy efficient in use as possible. It is obvious since these kinds of appliances consume lots of energy nowadays. Probably Harry does not immediately know how to solve this problem. After a while, he probably decides to consider 2 options for energy saving. The first option is to use more efficient technologies, such as new cooling technology, but probably they are already used in the newest versions of mobile air conditioners, so it will not provide extra saving. The other option is to reduce the energy which is wasted during the use of mobile air conditioners. But to achieve it, the product needs a kind of control function to influence or optimize the energy balance of the product. After this, Harry will consider possible control functions which he could add to reduce the wasted energy. Being an experienced designer, Harry has multiple solutions in mind for this. But he also faces the problem of finding the best one. His main concern is that he doesn't know all the solution possibilities. To end up with some solution, he compares the alternative solutions and the influencing factors, knowing that the extra cost of the control function cannot be higher than the achieved savings. Harry knows that he is not supposed to waste a lot of time on this initial decision because he has a fixed deadline. He feels that he has too many pieces of information which does not allow him to see the complete picture. On the other hand, he misses information about what control technologies and control solution to prefer. The abstract prototype will show you how we think the proposed tool can support. In order to provide you information about the working principles and the technical features of the tool, let's look into more technical details. First of all, we conceptualize this tool as an online software application which can be accessed from anywhere and anytime. The concept of the tool relies on single user-oriented architecture. As one of the most important principles of the operation and use of the tool, we assume that it should be in harmony with the reasoning that experts do when they try to solve similar problems. They typically use knowledge of other past cases and compare it with the current case. They typically extract from these past cases the information about the product prices and the costs of energy used in operation. They can also infer about possible savings and usable energy controlling technologies. We see as a task of the tool to support this knowledge aggregation and processing activities of the designers. But the tool should also share its knowledge with designers about the gains and savings that can be achieved with these controllers and should rank the solutions accordingly. Having introduced these pragmatic principles, we can detail the practical operation of the tool. You should also know that the operation of the tool includes 4 major phases which are needed to get to a trade-off situation. The tool should support the specification of the new product characteristics, the search for energy-saving solutions, to adapt the product use histogram, and the last phase to calculate the trade-off. Obviously, this short overview cannot provide you with all necessary details about the operation of and problem solving with the tool. But don't worry. Further information about the operation and interaction of the tool will be shown in different other modules of this demonstrated abstract prototype. Each of these modules will highlight a different functional unit of the tool and will also cast light on the complete problem solving and use processes.